Now there's a bit of a problem here, and this is the focus of the video. We don't know what the difference is between the ignore course of action and the missing course of action. All we get for the missing course of action is this conditional, this if-then. If all data points in the ER are missing, then the alarm transitions to that state insufficient data, one of the three categories. But what if they're not all missing? Perhaps only some of the data points in the evaluation range are missing, and we're given no instructions for that scenario. So we're not given a complete account of what happens when you instruct CloudWatch to treat missing data as missing. The reason this is a problem in the first place is that clearly if you ignore something and treat it as missing, how is that different? They just sound like you're not paying attention to it. What does the difference consist in? They just sound pretty similar to me. Ignore and treat as missing. Here's a possible solution. The first priority is always going to be check the evaluation range for any breaching or non-breaching data points if we have missing data. And this is why we're told that whenever we evaluate before determining a change of alarm, we look at the ER. So we're only interested in situations where you really are forced to take a course of action on a missing data point. You've already exhausted the ER. So here are some first thoughts on the difference between TAM, treat as missing, and ignore, those two courses of action. So imagine we've got an alarm with an evaluation range of 5, an evaluation period of 3 data points, and also data points to alarm is 3. So really we want 3 consecutive breaches before we're going to go to alarm. So I've thought of 3 points of difference. So this is what we've got. The 3 most recent data points have had no data, and then we've had 2 older ones with data. And the question is, what state do we put this alarm in? So we might say that with treating data as missing, it's as if there's no data point, whereas so it's not even on the pie chart, it's not in any of the categories, whereas with ignore, we're saying there is a data point, it's just that it has no data. So it is in that category. Second point of difference, with ignore, what we're doing is deferring to the previous alarm state. There's no novel determination of alarm state occurring. We defer, we fall back on whatever the previous alarm state was. Just ignore it when it says see the blue categories above. They're the alarm states in that diagram I had before. So let's suppose that the previous alarm state was okay, and that used these 3 data points in the blue box here because the EP is free. So what's going to happen is that's going to just inform this alarm state. So we just defer to the previous alarm state. So it would in this case be okay. With TAM, on the other hand, treat as missing, we're striving to arrive at a novel alarm state. We're coming to our own independent determination. This novel alarm state may happen to be the same as the previous alarm state, but it's not necessarily. So there's an important difference there. And the third point of difference, and this is related to the previous one, is that with treat as missing, we're scrambling real data points, so retrieving from the past data points that have value, real data points. So we're going back, and I've shown here that we're scrambling beyond the evaluation range. Why you might think this occurs, I'll get to in a moment. Whereas with ignore, well, because we're deferring to the previous alarm state, there's no need to scramble. So there's 3 points of difference. With TAM, we're not even acknowledging the existence of the data point. We are with ignore. We're striving with TAM to get an alarm state, whereas we're just deferring to the previous alarm state with ignore. And we're scrambling data points with TAM, and we're just we're not with. Now you might think deferring to the previous alarm state and scrambling old data points, they're both sort of going back in time. They're basically the same thing, but not necessarily. Let's try and bring this out. So again, we've got an alarm with an evaluation period of free and data points to alarm as free, and the most recent 2 data points have had no data, and then we've had one with data. So if we start off trying to determine this alarm state, that's why it's got a question mark. We're going to look at these 3 data points. We've not got enough, so activate the evaluation range. We're going to look at now 5. Well, we still haven't got enough for our evaluation period because we need 3, and there's only 2 with data here. So you can see we've only got 2. So what do? We scramble, or so we're saying at the moment. And now we have got enough for the evaluation period, because we've now got 3 real data points. Now here it happens to be the case that all 3 are above the threshold. So we've got 3 breaches. So what's going to happen? Well, data points to alarm is free. We've got 3 breaches. So we can now determine the state of the alarm as alarm. Remember, it's either OK, alarm, or insufficient data. Okay, so that works. So, but now let's suppose our course of action was not TAM, treat as missing, but ignore, right? If it was ignore, we'd defer. Remember, we just defer to the previous alarm state. So let's suppose the previous alarm state was OK. Why would it be OK? Well, it would have looked at these 3 data points, because they're that's the next chunk behind in time. Well, it can't have used those only because it needs 3 to look at. It needs an evaluation period of 3, and there's only 2 with data there. So what it would have done is gone further back to these 3. Fortunately, these 3 do have data in this evaluation period here. They're all non-breaches, so that would have been OK because we've got 3 non-breaches. And let's say it got that state of OK from that alarm. So that's how that alarm was OK. And of course, that would inform this alarm because we're deferring, we're using the ignore strategy. So that wouldn't be alarm, that would actually be OK. So you can see that's how they come apart. When we were using TAM, treat as ignore, that alarm was alarm in the alarm state, and when we're using ignore, it's in the OK state. So that's how they come apart. So deferring isn't necessarily the same as scrambling old data points. So where have I got this idea of scrambling old data points from? Well, in this book by Ben Piper and David Clinton on page 200, they have this page where they say missing data can occur. This may happen if you detach an EBS volume or stop an instance, and they say we've got these following 4 options, and this is kind of their bit, which is equivalent to this part in the docs where they say you can do any of the following: not breaching, ignore, missing. And so they start by explaining TAM, or treat as missing, and they say this treats the period missing data as if it never happened. For instance, if over 4 periods the data points are 41, no data, 50 and 25, CloudWatch will remove the period with no data from consideration. If the evaluation period is free, like it has been with us, it will evaluate only 3 periods with the data points 41, 50 and 25. So it's kind of just cut out the one with no data. It will not consider the missing data as occurring in the evaluation period, and that's the default setting. And this is where I got that first, this is kind of what influenced me to put that first row, that first point of difference where I said with treat as missing, it's as if they're saying there is no data point. It's this fact that they use this language of it doesn't even consider the missing data as occurring. They say it never happened. This is kind of as they're speaking as if it's stronger than ignore. So this is what they say. They say if over 4 periods we've got, say, 41 no data, 50 and 25, you need 3 real data points because your EP is free. So even though we'd normally just consider these 3, we're kind of going to scramble, go retrieve slightly more historical data and use that. And we reach back to get the 41, and now we've got our EP. So that's where this idea of scrambling came from, and that's why I'm associating it with TAM, or treat as missing. And by the way, there's no mention of the evaluation range in this book, the red period that you go to in an emergency. So the problem is this, just to put it in more specific terms now, we haven't been given a complete account about how CloudWatch behaves when you specify it to treat missing data points as missing. Okay, we haven't been given a complete account of what happens with this fourth category here at the bottom. Because what it gives us is a condition that says if all data points are missing, then go to insufficient data. Okay, so if it's like that, go to insufficient data. Okay, that's fine. But what if some data points are missing? Okay, what if it's like that? What happens then? So it's clear that CloudWatch will go to insufficient data in this situation. No data, no data, no data, no data, no data. Okay, and it won't scramble. I'm pretty sure that it won't scramble, even though I've associated the idea of scrambling with treat as missing. But it's not going to be saying something false there. So the question is, what if some and not all of the data points in the ER have no data in the evaluation range? So maybe it's like that. I think there are some possible answers here. Answer one is that CloudWatch scrambles data points. It fills up the evaluation period, going back as far as it needs to, and as soon as it keeps searching, going further back, and as soon as it fills up the EP, it's happy. But this is a problematic answer, actually, because how far back? You could have a situation like this. We've had the two most recent points with data. I don't know, maybe that looks like it's maybe a breacher, that one's a non-breacher. But before that, there was no data for a long time. And if we're saying that the procedure really is to scramble to retrieve historical data, fill up an evaluation period going as far back as it needs to, let's suppose the evaluation period is free. Imagine if it goes all the way back to there. It just seems a bit bizarre. I mean, look at this situation. It's only the single most recent data point that had data. And if it scrambled until it got free real data points, it would go back here. Let's suppose these were breaches, and it would go into an alarm state, and that kind of seems intuitively unsatisfactory. That is mostly not breaching. It's more not. There's a greater number of non-breaches, or there's a greater number of alarms that are not such that they are breaches there than there are breaches, but that would go to alarm state. They do actually say in the docs, suppose an alarm's most recent data is breacher, right? 1, 2, 3, 4 breacher. We've just had a breacher. It's been the first time we've had a real data point in a while. So with 4 missing data points and then a breaching data point as the most recent data point. So I'm just saying they have this weird passage where they kind of cover a situation like this. Because the next data point may be non-breaching, in other words, with data, the alarm doesn't go immediately into alarm state. Okay, so it doesn't go into alarm state when the data is either breacher or breacher no data. And this way, false positives are avoided when the next data point is non-breaching and causes the data to be, if you had 1, 2, 3, 4 breacher, the next one it would be breacher healthy, or breacher no breacher, or if you had this one, breacher no breacher, then obviously you'd have breacher no breacher, non-breaching. So they put this logic into the alarm to make it such that if you have a kind of blank canvas of no data and the most recent or the almost most recent data point is a breacher, we're actually just going to hold back and not go to alarm state. But anyhow, So they comment on this kind of situation. But anyway, back to where we were. I still think that this idea of reaching all the way back is kind of absurd. Yes, answer 1 might still be true, but if historical data points were able to determine the state of the alarm in this way, I think this would be mentioned explicitly in the docs. You know, look at that. That's ridiculous. So I'm going to rule out this unlimited scrambling for data points. So back to this textbook, they said if over 4 periods you have 41 no data, 15, 25, why then did they suggest this idea of scrambling? Well, they're probably describing limited scrambling. Okay, so scrambling confined to the evaluation range. So we're not going to go miles back. We're going to go back, 5. Stay within 5 data points, because that's the example they always use. And AWS always use in the docs. They have an evaluation range of 5. So that's limited scrambling, right? In this textbook, they're not describing unlimited scrambling. However, their passage is now misleading in 2 ways. I'm not saying this is a fault of the authors. It would have been accurate at the time. It's just that the technology has changed. So this is their page. Couldn't get it without scribbles on, but they go through and they say these are the 4 things: as missing, not breaching, breaching, ignore. So, and of course we're focusing on the difference between as missing and ignore. This is their kind of paragraph equivalent to that in the docs. And the 2 ways it's misleading is that firstly it suggests that TAM, treat as missing, exclusively scrambles for data points, reaches back to data points which have data. But actually the ignore course of action scrambles for data points as well. Secondly, the second way it's misleading is that in fact all 4 courses of action reach back for data. Limited scrambling within the ER. Secondly, they suggest that, or they describe the ignore course of action kind of too strictly. So they say with ignore, the alarm doesn't change state until it receives the number of consecutive data points specified in the data points to alarm setting. The current AWS documentation would suggest that isn't correct. I believe that consecutive data points are not required. So if the data points to alarm is 3 and you've got 3 breaching data points in the ER, they will put the alarm in alarm state even if they're not consecutive. I believe that to be true. Okay, so they provide these tables, which are quite intimidating at first in the docs, but we'll break it down, which show how the 4 courses of action come apart. So here we're assuming that we've got data points to alarm as 3 and the evaluation period is 3. So basically we want 3 breaching data points, and because it's the evaluation period also being 3, we look at the 3 most recent data points. So let's look at this column, the ignore. And I've said that ignore is all about deferring to the previous state. It's hard to tell even what ignore does. I just want to point out here that sometimes they put OK, sometimes they put alarm, and obviously those are 2 possible states. Remember the 3 categories of alarm. And sometimes they put retain current state. Okay. Now the assumption that I'm going to make is that when they don't write retain current state, there's enough present to not defer. Okay. So I'm presuming that when they put OK, they don't mean when they put OK, it's not deferring to the previous state. Otherwise, they'd put retain current state. When they put alarm, it's not actually deferring to the previous state. Otherwise, they'd write retain current state. So that's an assumption I'm going to make. Maybe it's wrong. Okay. Now, let's see. So what's confusing about this table is that on row 2 and row 5, which I've put in green here, we've got 2 data points that need to be filled because look, we've got an evaluation period of 3. We've got 1 data point with data. Okay, it's a non-breacher, but we need 3, so we need 2 more. So we're in need of 2. And similarly here, we've only got 1 data point with data. It's a breacher in this case, but still we need 2 more to make our evaluation period, because our evaluation period needs to be 3. So they've put we're in need of 2 data points in both situations. So as far as I'm concerned, I know we've got a non-breacher and a breacher, but as far as I'm concerned, they're exactly the same, these 2 rows. So I'm wondering why this row turns out to be OK. It puts the alarm into OK state, whereas this one causes them to put retain current state, as if it's deferring back to whatever the previous state was. Maybe it was OK, but maybe it was alarm. So what is it about the fact that this is a breacher that means we're deferring? Why aren't we deferring to the previous state here, or retaining the current state here? We've not got enough for an evaluation period. I don't think they explain anywhere why that is. So I'm confused about that discrepancy there between that and that. Something else which is interesting here. Something called the special procedure applies to the 5th row. Okay, so there is actually something that I've noticed that's different in virtue of the fact that this is a breacher rather than a non-breacher. Now I'll go over the special procedure in a minute, but moral of the story is the special procedure means that this row should go to alarm state, because we've got it. Basically, this special procedure says if you've got a breacher and it is within the evaluation period from the present time, which it is because it's free back, and it's at least as old as the data points to alarm, which it is, and it's only got data points with no data since then, or breaches since then it should go to alarm. But it doesn't go to alarm, so that's also very confusing to me. Just ignore all that if it doesn't make sense to you. I'm going to go over that in a minute, but anyway, I'm just saying row 5 I cannot explain. This row makes sense, the fact that they've put OK here in row 1. So I'll just explain why. We've got an evaluation period of 3, we've got 1, this is the evaluation range, which is 5. For some reason they've just chosen 5. It's kind of a model, which is the number of data points they look at to make the determination of the alarm state. It actually varies in every case, but the principle is the same if we assume it to be 5. So they're always going to assume the ER is 5. So we've fortunately got 3 data points with data in the ER. So we've got enough for our EP, our evaluation period. But we've said that the data points to alarm until the alarm is free, so that's not fulfilled. So we can't go to alarm because we'd need an X and actually another X for that. But we've got that non-breacher there, so we're actually going to go to OK, and we can positively determine it as OK. So that row is very understandable. I can also explain row 4, this row here, that they've put alarm in, because yes, we've got some missing data here, the dash. However, we've got, if we use the most recent principle, we've got a breacher, a breacher, and a breacher. So we've fulfilled the evaluation period, and that's also the data points to alarm filled, because we've got 3 data points that are breaching. So that can positively be said to be in the alarm state. Okay, so that can be explained. They do fulfill the DTA, yep. But just a second thing that is actually unexplainable to me is the fact that row 2 is put in the OK state, and while row 3 is put in the retain current, they've put retain current state. It's the discrepancy there. I mean, if you look at row 2, they've only got 1 data point with data, or one real data point. It's this one, which is non-breaching with the 0 there. So we haven't got enough for our evaluation period. And they've put OK, right? Now maybe that's the way it is. Maybe when you choose ignore, the rule is when you don't have enough for the evaluation period, we go to OK. Maybe that's the rule. Now you might be thinking, I thought the rule was you defer to the previous state. So did I. If that's the case, they should have written retain current state there. Here we've got no data at all, and they have written retain current state. But why is it that as soon as we have 1, 0 here, one data point which is non-breaching, it's OK rather than retain the current state? Okay, neither row has an evaluation period. We don't have 3 data points to play with in both of these purple circles, right? So I cannot fully understand the behavior of the ignore course of action. So this is from the Piper and Clinton textbook. What's going on here? So they say with ignore, the alarm doesn't change state until it receives the number of consecutive data points specified in the data points to alarm setting. Alright, yeah, so this is just showing that in the docs, it's not necessarily true because we've got a breacher, a data point with no data, and then a breacher. And then another breacher, there we go, yeah. So we've got 3 breaches, but they're non-consecutive. So, yeah. And it's gone to alarm, and that presumably means it's changed state, and that makes sense. But yeah, they're not consecutive. So previously we were saying maybe the solution to what happens when only some of the data points in the evaluation range are missing data. Right, we know what happens when they're all missing data. We go to insufficient data, but when some of them are missing data, maybe it scrambles. And I said actually unlimited scrambling, going all the way back as soon as doing whatever we can to fill the EP, the evaluation period. Actually, that's a bit bizarre, so I'm going to rule that out.